Good morning, everyone. I'm Maheswari, AP Chemical Department, RMD Engineering College. This video, I'm going to discuss about the topic optical pressure and temperature sensors, which is in the sensors and transducer fourth unit. So, in this particular unit, we'll discuss about the photoconductive cells. So what is a photoconductive cell? The photoconductive cell is a two-terminal semiconductor device, and it is used to convert the light energy into electrical energy. Its resistance is varying linearly with the intensity of the incident light. It is also known as photoresistive device. So the principle of this photoconductive device is the light striking on the surface of a material provides sufficient energy to cause electrons within the material to break away from their atoms. These free electrons and holes or charge carriers are created within the materials, and because of this the resistance is reduced. Because of the increase in the free electrons, its resistance is reduced. This is known as photoconductive effect. So now moving to the construction of this photoconductive material. So this photoconductive material, it is a light sensitive material, and it is arranged in the form of a long strip zigzagged zigzagged across a disc-shaped base. So the connecting terminals are fitted to this photoconductive material on each side of the strip, and they are at the ends of the strip. Thus, the light sensitive material is a short, wide strip between the two conductors. For the production, a transparent plastic cover is included over this strip. Now, the materials used for this photoconductive cell is cadmium sulfate and then cadmium selenide, and these two materials used in the photoconductive manufactures. So, what is photoconductive effect? So this photoconductive effect, it consists of thin film of semiconductor like selenium or thallium sulfate placed over a thin film of semi-transparent metal. The iron base and the transparent metal is connected through battery and the resistance. When the light falls on the cells, its resistance decreases, and hence the current starts flowing in the external circuit. So this is your diagram where you can see that it is made up of a selenium material, and you have an upper material is a semi-transparent material. So whenever light falls on the cell, the resistance of the cell decreases, and the current starts flowing in this external circuit. So that is represented by this diagram. So the characteristics and parameters of this photoconductive cell. Now, when the cell is not illuminated, its resistance is greater than 100 kilo ohms. And this resistance, this high value of resistance is known as dark resistance of the cell. Now, when the cell is illuminated, its resistance will fall to or reduce to a few hundred ohms. So, the scales of this illumination characteristics are logarithmic in nature. Now, the maximum voltage and power dissipation, the dark resistance and the resistance at under lux illumination. All these details is given in the representation. The light wavelength that gives the peak response is known as lambda p. The cell sensitivity is used to simplify the cell current for a given voltage and the given level of illumination. Here you can see the graph. It is a graph between the illuminance, illuminance lux along the x-axis and the resistance along the y-axis. From the graph, you can observe that with the increase in the lux illumination, the resistance is reducing, which means that more amount of free electrons are conducting. So this is about the photoconductive cell. Our next topic is photovoltaic cell. So, or the other name is solar cell. So, this is the constructional diagram of the photovoltaic cell. So, what is the principle of this photovoltaic cell or this solar cell? Now, the photovoltaic cell is a semiconductor device which is used to convert the light energy into electrical energy. The voltage induced by the PV cell It depends upon the intensity of the light incident on it. The photovoltaic, it is named because of the voltage producing capability of it. Now here, in this the electrons of this semiconductor materials are joined together by the covalent bond. The electromagnetic radiations are made up of small energy particles called photon. When the photons are incident on this semiconductor material, then the electrons energized and it starts emitting. So in this manner, the electrons are generated. So the energies or the electrons is known as the photoelectrons. And this phenomenon of emission of electrons is known as photoelectric effect. This working of this photovoltaic cell depends upon this photovoltaic effect. Construction of this photovoltaic cell, the semiconductor materials used here is arsenide, indium, cadmium, silicon, selenium, and gallium are used for making this photovoltaic cells. So mostly silicon and selenium are used. Now, in the construction of this photovoltaic cell, the upper surface of the cell is made up of thin layer of p-type material, and so that the light can be easily able to enter into the material. The metal rings are placed around the p-type and n-type material, which acts as their positive negative output terminals. Now, the multicrystalline or monocrystalline semiconductor material make this single unit of the PV cell. The output voltage and current obtained from the single cell is very less. So the magnitude of the voltage, it is around only zero point 0.6 volt, and the current, it is very less. So different combinations of cells are connected for increasing the output voltage and the output efficiency. The working of this PV cell. So when the light incident on the semiconductor material, it, it may pass through or reflected through it. The PV cell is made up of semiconductor material which is neither a complete conductor nor an insulator. This property of this semiconductor material makes it more efficient for converting the light energy into electrical energy. So when the semiconductor material observes light, the electrons of the material starts emitting. So this happens because the light consists of small energy particles called photons. When the electrons observes the photon, they become energized and start moving into the material. Because of this an electric field, particles move only in one direction and they develop a current. The semiconductor material have the metallic electrodes through which the current goes out of it. Now, this is here PV junction solar cell with resistive load. So in this, PV cell consists of p-type layer and n-type layer of semiconductor material. These layers are joined together by an p-n junction. So the junction is the interface between the p-type material and the n-type material. When the light falls on the junction, the electron starts moving from one region to another. So in this manner, the electrons are flowing and the current is generated. Thank you everyone.